Good morning, dear students. My name is Ferhan Mazher, and today is 22nd March of 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper, and we have selected May-June 2014 2-2 paper. This paper belongs from the Zone 2, or you can say Variant 2. We have already done a video on this paper and we have solved in that video the section A of this paper. Today in this video, we are going to attempt the section B of this paper. The section B has 3 questions and we will solve them. So hopefully you will enjoy this video and you will learn from this video. So let's start today's paper. We are going to attempt the section B of this paper, and here we go. The question number 9 is coming up on your screen. So a children's ride consists of a steel cable that runs between 2 posts of different heights as shown in the figure 9.1. So here we have 2. This is the larger post, this is a smaller post, this is the wheel. So with the help of this wheel, this girl will we call it zip line, and she will come down on this steel cable by the help of this wheel. A girl starts and finishes the ride at rest. Her horizontal motion can be taken as an initial uniform acceleration for 3 seconds followed by a constant speed of 2.4 meter per second for a further 5 seconds and a final uniform deceleration that lasts for 1 second. On the figure 9.2, draw speed time graph for the horizontal motion. Okay, so here a speed time graph is given, and on the y-axis we have speed, on the x-axis we have time. So if you, for the first 3 seconds, the girl started from rest, so 0,0, put a dot here. After 3 seconds, she will achieve a speed of 2.4 meter per second. So we'll put a dot on 2.4, and then for the next 5 seconds, she continued that with that speed. So up to 8, 2, 4, 6, 8, she will move with this speed. And then in 1 second, she will decelerate and she will come to rest. So let me show you how this is done. And this is question number 9. Okay, so here we go. So the question number 9 is coming up on your screen. You can see here I have labeled this as 0 to 4. This is the showing the speed on the y-axis. Here the time is represented 2 seconds, 4 seconds, 6, 8, and 10. So in the 3 seconds, she achieved a speed of 2.4. Her acceleration was constant, so that's why it's a straight line. Then for the next 5 seconds, it means from 3 to 8 seconds, her speed remained constant at 2.4. So it's remained constant. And then in 1 second, she goes to rest. Her speed becomes 0. So this is the speed time graph which we will draw. So hopefully you understand. Okay, so the next question. Explain what is meant by the uniform acceleration. A body, if is moving in such a way that there is an equal change in the velocity in equal intervals of time, we say the body is moving with the uniform acceleration. So let me show you my written answer. Equal change in velocity in equal interval of time, we say that the body is moving with the uniform acceleration. The final deceleration is larger in size than the initial acceleration. Explain how the data shows this. Okay, so how the data shows this? To achieve the speed of 2.4 seconds, the girl took 3 seconds. From rest to go to 2.4 meter per second speed, she took 3 seconds. But she took only 1 second to go from 2.4 meter per second to 0. So it means that the deceleration is larger than the acceleration. I hope you understand my description. Okay, so let me show you to explain you. Okay, so you see, to achieve this speed of 2.4, she took 3 seconds, but from 2.4, she went to 0 only in 1 second. This means that this deceleration is larger than this acceleration. So let me show you Speed went from 0 to 2.4 meter per second in 3 seconds, but it went from 2.4 meter per second to 0 meter per second in 1 second. Hopefully you understand. Okay, so this is the marking scheme coming up on your screen. Question number 9A part. So you can pause the video and you can check the answers. Okay, so we are done up till C point, C part. Now, D part, he says calculate the horizontal distance traveled by the girl in the first 8 seconds. So if you want to calculate the distance traveled by the girl in the first 8 seconds, and that will be equals to the area under the speed time graph. So we can very easily calculate, and hopefully you will understand this. Sorry. Okay, so here we go. So the area under the speed time graph. So area under the speed time graph, that shape up to 8 seconds is in the shape of a trapezium. So we can find the area of that trapezium. The formula is very simple. It is 1 by 2 into 2.4 into 8 plus 5. And it will be 1.2 into 13, and that will be 15.6 meters. So approximately 16 meter is covered. Let me tell you how this is done. Okay, so this up to 8, it's a trapezium. These are the two parallel sides of the trapezium. This side is 8, this side is 5, and the height of the trapezium is 2.4. So let me show you from there. Okay, so 1 by 2 into 2.5 into 8 plus 5, and that will be 1.2 into 13, and it will be 15.6, which is approximately 16 meter. So let me check the answer from the marking scheme, and we will have, okay, so let's check from the marking scheme. So if they say this is 15.6 meter or 16 meter, yeah, our answer is right. Okay, so we are going to the next part. That's the D part. He says the girl has a mass of 30 kg and falls a vertical distance of 1.6 meter during the ride. The gravitational field strength G is 10 Newton per kg. Calculate the decrease in the gravitational potential energy of the girl. So we can find out the gravitational potential energy, the drop in the gravitational potential energy. The formula is mgh. Simple formula. You just apply the formula and you will be able to find the drop in the gravitational potential energy. So the loss of the gravitational potential energy is equal to mgh. So it will be 30 kg multiply 10 Newton per kg multiply 1.6 meters. So it will be 480 joules. 480 joules is the answer. Okay. Then he says the gain in the kinetic energy of the girl is less than the decrease in her potential energy. So just one reason for this, you see, the loss in the gravitational potential energy was supposed to convert into the kinetic energy. But the gain in the kinetic energy is not that much, is not equals to the loss in the gravitational potential energy. The reason is very simple. And there is air friction acting on the girl, and there is friction between the wheel and the rope. And due to that, the energy converts into heat, which is lost to the surrounding. So some of the energy is converted into heat. So wheel has friction with rope. So to overcome it, some energy converted into heat. So that is how we do it. And then he says the gain in the kinetic energy of the girl. We are done with that. A group of people, the group of people make measurements to show that the girl's speed is constant during the middle section of the ride. Suggest what measurements are made and how they show that the speed is constant. What you can do, you see this girl is, so on the ground, you put marks, additional marks, we call it, and you put them on equal distance. For example, you put them after 1 meter, or you put them after 2 meter. So the additional marks or marks on the ground should be put at equal distance, and somebody should look that at what time she crosses which mark. you should note down that at what time she is on which mark on the ground. And then what you will observe that the distance, the time lapse between one mark to the other mark to reach the from one mark to the next mark, in the middle of her drop, that the time lapse will be same for the consecutive, um, you see, traditional marks. So that will show that she has covered equal distance in equal intervals of time. So the speed is constant during the middle section of this drop down. Okay, so let me. It's a 3 marks question. It's a tricky thing, and it's the last part of that question. Okay, so let me show you. Okay, they put mark on the ground, fiducial marks. The marks we put on the ground, we call it fiducial marks at equal distance apart. Then note the time when she crosses each point. The time lapse to move from one mark to the other in the middle of travel will be equal. This shows that the speed is constant in the middle of the travel. I hope you understand this question. Okay, so let's look at the marking scheme for this part and the previous parts. Okay, so we are done with 480 joules heat or thermal energy or sound produced or work done against the friction or air resistance. At least 2 distances and corresponding times mentioned. How the actual measurements is made. For example, anyone from make mark on the ground every second and measure distances. Note video position. You can also record her when she's traveling. You can record the video, and by video you can very easily tell that she at what time she is on which mark. Every second, and use a scale to find distance, make a mark on ground every meter and measure time, take times as girl passes. How constant speed is proved using the measurements. For example, anyone from same distance between each position for the same same time interval for equal distances, and the change in the distance by the change in the time constant or slope of distance time graph is constant. So hopefully you understand. So that was the question number 9. It's marking scheme. You can pause the video and you can have a look at this marking scheme, and you can take your time and read it carefully. So we are done with the question number 9. So let's move to the next question. The next question will be question number 10. He says, okay, so the 2 metal saucepans containing the same mass of hot water at the same initial temperature. Pan A is white and the pan B is black. But otherwise, the 2 saucepans are identical. Both saucepans are uncovered and cool under the same conditions. The cooling curves for the 2 saucepans are shown in the figure 10.1. So their initial temperature is, I think 94, and during the 8 seconds, 8 minutes, sorry, and the temperature of the pan A has dropped from the 94 to, I think, how much is this? It's something like 60, and the pan B, its temperature dropped from 94 to 40. Yeah, 40. Yes. So to make it more easy for you, so you can read it. So you see, the initial temperature is 94, and the final temperature for the pan A and the B is 60 and 40. Pan A 60, pan B 40. Hopefully you understand this. Okay, so the question is, describe how the water in a pan loses heat by conduction. You see the the molecules of the saucepan which are in contact with the water, they will absorb heat from the water and they will start vibrating vigorously. And the amplitude of their vibration will increase, so they will collide with their neighboring molecules and they will make them vibrate vigorously. So by the vibrations, the energy will be transferred from the hot end to the cold end. So the conduction is basically taking place in the solid, which is the saucepan. Okay, so let me go to molecules at the hot end absorb heat, their amplitude of vibration increases, they transfer energy to neighboring molecules by colliding, and thus energy reach the cold end. So this happens by the vibration of molecules. Okay, so the next part which they are going to ask us is convection. You see, the convection will be happening in the air which is above the water and hot water, and the air molecules which are comes in contact with the hot water, and the air molecules move away from each other. The density of the air molecules decreases, so that this less dense air rises upward, and the cold and dense air which is above that sinks downward. In this way, the convection currents are set in, and the heat is taken away from the water. So I have written that the air absorb heat, its particles move away from each other, air becomes less dense and rises up, cold air being dense sinks, and the convection currents are set in. So hopefully you understand. Okay, so he says explain why the pan B cools faster than the pan A. The basic reason is because there is a difference in their color. The pan B is has black color, and the pan A has a white color. So because the black color is a very good radiator of the or emitter of the infrared radiation. So, and the white color is a bad emitter of the infrared. So the black one, the saucepan B, the hot water in it will cool faster. That's why its temperature uh, dropped more. So B has black color, which is a very good emitter of infrared. A has white color, which is bad emitter of infrared. So that's why there is difference of the temperature drop in both the saucepans. The B will have more temperature drop. Okay, so let's move to the next part. He says, describe and explain how the figure 10.1 is different when the pans are covered and the experiment is repeated. Now, if you cover the pans, both the pans, what will happen? The cooling will become slow because you have covered the pans. Obviously, now the evaporation cannot take place, and the heating, the loss of heat will become slower. So the temperature drop will be less in the same time in both of them. Okay, both pans will take longer time to cool down due to cover, less evaporation and less convection will take place. I hope you understand my answer. Okay, so let's move to the next part. He says, the specific heat capacity of water is 4200 joules per kg per degree centigrade. Explain what is meant by a specific heat capacity. Specific heat capacity means that the amount of energy required to raise the temperature of a body of 1 kg through 1 degree centigrade. This definition you have to write word to word. Every word is very important in this definition. Let me show you my written definition. Amount of energy to raise the temperature of 1 kg substance through 1 degree centigrade. That is known as specific heat capacity. Okay, so let's go to the next part. And he says the specific heat capacity of water is very high. So just one disadvantage of this when water is used for cooking. You see, if the water has its specific heat capacity is higher, so it will take more energy to raise its temperature. If you want to boil the water, it will take more energy. And so for especially for cooking purpose, more time will be taken to raise the temperature of water so the cooking can be done. So very simple answer. Okay, so let me show you my answer. And I says it takes more energy to raise the uh, temperature of water. So that creates it takes longer to cook. He says the water in a pan A cools for 8 minutes as shown in the figure 10.1. During this time, the water loses an average of 9,000 joules of thermal energy per minute. Calculate the mass of the water in the pan. You see, it takes 8 minutes to cool. Okay, so 9,000 joules of energy is being released per minute. So in 8 minutes, how much energy will be released? 9,000 multiply 8. So you know how much energy is released. And we know the temperature drop in the pan A. From where do I know the temperature drop in pan A? The temperature of the pan dropped from 94 to 60. 94 to 60. So I know the change in the temperature of the pan A. So I can calculate the mass of the water. Okay, so very simple question. Okay, so let's see this. So heat is equals to mc delta theta. Heat will be 9,000 multiply 8 because in 1 minute 9,000 joule energy is lost. So for in 8 minutes 72,000 energy will be lost. And the C specific heat capacity of the water is given. That's 4,200 joules per kg per degree centigrade. The change in the temperature is from 94 to 60. That's 34. So 72,000 equals to M multiply 4,200 multiply 34. So M will be 72,000 divided by 4,200 divided by 34 equals to, and that will be 0.5042 kg. Or if you want to write the answer in grams, you can say you multiply it with 1,000, it will be 504.2 grams. In kg, the answer is 0.504 kg. Hopefully, you understand this numerical. Okay, so let's go to the next question. He says, the mass of water in the pan B is the same as that in the pan A. Calculate the thermal energy lost from the water in the pan B in 8 minutes. So 9,000 energy in 1 minute. So in 8 minutes, we can get 72,000 energy. But the temperature drop in the pan B is from 94 to 40. So it's like something 54. The change in the temperature for the pan B is 54. So very easily we can calculate. Here we go. So heat is equals to, sorry, heat is equals to, in my description, I said 9,000 multiplied. That is not here. Heat lost, we have to calculate, sorry. So heat is equals to mc delta theta. The mass of the water in the pan B is same as the mass of water in the pan A. That is 0.50 kg, and the C is also same, 4,200 joules per kg per degree centigrade. The change in the temperature is 54. Just use the formula heat is equals to mc delta theta. So you will have 114,307.2 joules. 11403 114,307.2 joules of energy is lost. Hopefully you understand. Okay, so let's go to the next part. Okay, so the this question is finished. One thing, when I was describing this second part, I said a wrong thing. I said the heat is 9,000 multiply 8 for the pan B. No, the heat loss for the pan B we have to calculate. Okay, so before going to the next question, let's open up the marking scheme. Also, my dear students, the marking scheme is in front of you. You can pause the video and you can read it. You can check my answers and confirm them. I advise you daily, whenever I solve a question, I tell my students that please check the answers, compare them with the marking scheme. It's a very important habit. Okay, so you are not supposed to think that our teacher is giving this answer, so it's perfect. No, always check the answer, compare it with the marking scheme. Okay, at least I tell my students, check, if I gave you the answer, please check the answer, compare it with the marking scheme. So I hope we got the same answer. They have rounded it off, and I hope that you understand this. Instead of 0.504, they are taking 0.5. Okay, so you can round it off. Otherwise, everything seems good. So let's move to the next part. Next question. The next question coming up on your screen is question number 11. A student sets up the circuit shown in the figure. So here we have a battery, 18 volt is the EMF of the battery, and here is a fixed resistor, and here is a 50 ohm resistor. Here's a movable contact. Here is a filament lamp connected with this movable contact. He says that R is a fixed resistor. Let me reduce the size so you can see the whole thing. R is a fixed resistor in the circuit. The filament lamp is marked 12 volt 0.25 ampere. The circuit is used to produce a current voltage graph for the filament lamp. The ammeter and voltmeter needed are not shown. To obtain different readings, the student changes the position of movable contact. On the figure 11.1, draw the symbols for an ammeter and a voltmeter in the correct positions. So you remember, if you want to add a voltmeter here, so it can tell you what voltage drop across the filament lamp, that should be connected parallel to the filament lamp. So I will draw it here. The voltmeter should be connected parallel to the filament lamp, and the ammeter should be connected here. It should be in series with the filament lamp. Ammeter is always connected in series with the device through which you want to measure how much is the current flowing. So let me show you. I have drawn that. Okay, so here we go. So you can see I have drawn here an ammeter that is in series with the filament lamp and a voltmeter which is parallel to the filament lamp. So this is what you have to do. Hopefully you understand. So let me show you question number 11. Okay, it says A part. Our answers are right. Okay, so then he says, explain why it is sensible to include the resistor R in this circuit. So why it is sensible to include a resistor R in the circuit? The reason is when you include a resistor here, it increases the resistance of the whole circuit. So the current coming from the battery will be not large, and there will be no danger of an excess amount of current passing through the filament lamp and overheating it and burning it, or you can say fuse it. So let me show you my answer, and then we will check from the marking scheme also. So it increases the resistance of circuit and current from battery decreases. So no danger of overheating of the filament lamp. So that is our answer. So let's look at the marking scheme. It says the R limits or reduces the current voltage, otherwise lamp blows, or more of the 50 ohm can be used to adjust voltage current. Okay. It is also used to control the voltage given to the filament lamp and the current flowing through the filament lamp. So it's for safety purpose. On the figure 11.2, sketch a current voltage graph for the lamp. Okay, you see here the current is represented on the y-axis and the voltage is represented on the x-axis. So the slope of this graph will be equals to I by V, and I by V means 1 by R. So the slope here is equals to the reciprocal of the resistance, because as you increase the voltage and the current, the lamp becomes brighter and brighter, temperature rises, so its resistance rises. So the gradient of this graph should gradually become smaller and smaller, because the slope here is equals to the reciprocal of the resistance. So gradually the slope should decrease, which means that the resistance is increasing. So the graph should look like this. Never forget this diagram and the positioning of the current on the y-axis and the positioning of the voltage on the x-axis. And what does the slope represents? So hopefully you understand. C part is correct divided by curved line from origin, correct curvature, decreasing slope. Okay, so our answers are right. Okay, so we are moving to the next part. He says, state and explain how a current voltage graph for a fixed resistor is different from the graph for a filament lamp. The graph of the fixed resistor, the resistance do not change. So its IV graph is always a straight line which has a positive slope, and it passes from the origin. Okay, so let me show you, because the fixed resistor, it obeys Ohm's law. So the current and the voltage are directly proportional. I have written grand here. It means graph. Sorry, this word is graph. For fixed resistor is a straight inclined line with constant positive slope and passes through the origin. And it passes through the origin. So hopefully you understand this thing. Okay, so let's move to the next part. He says, figure 11.3 shows the positions of the movable contact with the voltage across the lamp is 12 volt and the current in the lamp is 0.25 ampere. Their first question is the current in the 50 ohm resistor. Remember these two, they are parallel to each other. So and the resistors or lamps or devices which are parallel to each other, it's a rule that they have the same voltage drop. So if this lamp has a voltage drop of 12 volt, the voltage drop here will be also 12 volt. So if you know the resistance here, if you know the voltage drop here, you can find how much is the current flowing here. So you can apply V equals to IR, I will be equals to V by R, and let me show you how this is done. Okay, so V is equals to IR, I will be equals to V by R. The voltage across the 50 ohm resistor will be 12 volt and the resistance is 50. So when you enter these values in your calculator, you will get 0.24 ampere. 0.24 ampere. Okay, so let me show you how this is done. And 0.24 ampere. Okay, so the next part is, he says the current in the R. The current in the R, so you see 0.24 ampere is flowing from here, 0.25 ampere is flowing from here. So here the current flowing will be this current plus this current. So the current through the R will be 0.24 ampere plus 0.25 ampere, and it will be 0.49 ampere. 0.49 ampere. Okay. So then he says the potential difference across the R, the potential difference across the R, the potential difference across the R. The potential difference across the R we can calculate very easily if I know here the 12 volts are used, and from the battery 18 volts came. Here 12 volts are used, so here you will have 6 volt. So 18 minus 12 and you will have 18 minus 12 and you will have 6 volt. And here we go, you got 18 minus 12 equals to 6 volt. So our answers are right. Okay, so then their question is, what is the resistance of the R? If you want to find out the resistance, you know the voltage drop, you know the current flowing through the R. So if I know the voltage drop here is 6 volt, I know the current flowing through here is 0.49 ampere, I can find the resistance. V equals to IR, and it says, let me show you the last slide. It says V equals to IR and R will be V by I. I know the voltage drop there is 6 and the current flowing through the R is 0.49 amperes. So 6 divided by 0.49, that will be 12.2 ohms. So it means the resistance there is 12.2 ohms. So let me check the marking scheme. So 12.24 ohms, okay, 6 volts, 0.49. So the question number 11 is done. So my dear students, we are done with this paper, and let me come to the end. Okay, so dear students, today we have done the May-June 2014 2-2 paper. In this video, in this session, we have completed the section B of this paper. The section A of this paper has already been done in another video that is already uploaded in that playlist in my YouTube channel. You can find this. So I have tried my best to explain you the concepts which were involved. I hope that this video will help you to do the past paper practice at your home. So if you find this video interesting, informative, and helping, please like this video, subscribe my channel, share the link of this video onto your Facebook accounts, into your Instagram accounts, and into your Twitter accounts, because when you do this helps me promote my channel, and it's like energy to me. So I feel blessed that I'm able to do some help to many students around the world. So thank you very much, everyone. Have a good day. God bless you all.